Hi everyone, welcome to Science at the Museum. We're here at the University of Michigan's Museum of Natural History, and my name is Jeanna. Today we're going to learn about exothermic and endothermic reactions. Before we start, we need to think about the words exothermic, endothermic. You've probably heard those prefixes before. Exo, you might have heard of things like explode, explore, and exit. All of those things have to do with things going outward and leaving. Endo, well, you might have heard of enter. Enter is about things coming in. The last word is thermic. Thermic, like thermal underwear, thermonuclear reactions, or thermometer. So thermo has to do with heat. Exo has to do with exiting, and endo has to do with entering. Let's move on to the next lesson. So today we're going to be looking at exothermic and endothermic with items that are found inside your kit. So the two things you'll be taking out of your kit today, you'll want to get out your ice pack, and you'll also want to take out the hand warmer pack, but also probably take out a cup or two. What we're going to do today is we're going to demystify how these work. We're going to actually open them up, check them out, and figure out which is exothermic and which is endothermic. So to do this, I'm going to open up my pack and peek inside. What do you see? You've probably always wondered what was going on in there. I know I always did as a kid. And so when we actually look inside, we see two things. We see some pellets. I'm going to pour them out so that you can see them. And I also see this bag. In fact, this bag is just water. And what we have in here is called urea. So these little pellets here right now are just room temperature, as is the water. I'm going to open up the water, add it to the pellets, and we can watch its temperature. Now, you could do this with a thermometer, and if you have one available, I would encourage you to use one. If you don't have one, you're actually going to be able to feel these reactions with your hands. So you'll be able to tell, even without a thermometer, if it's exothermic or endothermic. Remember to think about which direction is the heat going. So you can try this at home. Open up your cold packs, mix the water into the pellets, and give it a very gentle swirl. Put your hands on the cup and just kind of wait a few seconds, and you'll start feeling it too. It's really getting pretty cold. I know you knew that already, but did you know if it was endothermic or exothermic before? So take a few seconds, think about it. Which direction is the heat going? My hand feels cold. So where is the heat going? Where is it coming from? So this is an endothermic reaction. The heat is in my hand initially, but the heat is getting pulled in to the reaction, into the reaction, endo. And so this reaction is feeling cold to my hand. Remember that cold is just the absence of heat. So the heat is leaving my hand and going into the cup. That's the direction, into the cup. Let's do another one. This one's pretty fun. I love these little hand warmers. So I'm going to go ahead and open one up. You might notice that right now, if you feel it, it's just room temperature. It's not hot or cold. Feels just like plastic. We're going to go ahead and open it up. If you read the directions, it says to make sure that you keep them closed until you're ready to use it. And since we are ready to use it, we can go ahead and open it. The reason for that is that this particular reaction uses oxygen. And so if you open it up before you're ready to use it and oxygen gets into the packet, this reaction will take place when you're not using it. Then you go to get it out of your drawer and you'll find that it is already done doing its hand warming. It won't do it anymore. So what you're going to do now is we're going to look at our pack. And when you first feel it, it really, again, still feels room temperature. But give it a shake, as it says on the directions. Loosen up the ingredients on the inside and give it a few seconds. You will begin to feel it slightly warming up. This one takes a few minutes to reach its full temperature, but yeah, it's starting to warm up now. So what you can do also is know that this is not just activated by oxygen, but it's also activated by the moisture in the air. The material that they make the package out of has small little holes for oxygen to get in, and it's also made of a material that somewhat retains the moisture out of the air as well, or moisture from our hands. So when you're holding it in your pocket, the moisture from your hand can also get in and also activate it. Both of those things will speed this reaction. So let's open this one up and see what's inside it too. Make sure that you're wearing some safety glasses and make sure that you are keeping this away from young children. It is safe, the ingredients that are in here, but it can cause irritation. And so better safe than sorry. We're going to pour this in. And again, if you'd like to get a thermometer, you can certainly do that. I'll go ahead and take one out of here. This one's going to be reading pretty chilly. It's only reading 18 degrees still. And I'm going to put it in here. And we will begin to see its temperature climb. Now, interestingly, you can try different things with these. You could maybe only add a part of the water to this one. Or in this case, you might try adding a tiny bit of water to it. Or you could stir it more and get more oxygen into it and see how that affects its rate of reaction. That would be kind of just a fun thing to try on the side. Don't add anything I haven't said, because that just wouldn't be safe. So as we watch it, it's moving up. Wow, it is already 38 degrees. So it is definitely warming up. So in this case, I'm touching it and I can feel the heat coming out of the cup. The heat is exiting the cup, so it is exothermic. Exothermic means that the heat is exiting the reaction. Let me share with you another example of an exothermic or endothermic reaction. You figure out which it is. So this is a really cool little heat pack. It is meant to warm your hands, much like these others, and it stays a liquid all of the time. It could stay like this for years until it gets activated. Now this one you don't have to cut open. It actually has everything it needs already sealed inside this. And if we read the directions, it says to bend the small metal disc until we hear a snap sound. So I'll go ahead and do that. Do you see that reaction happening? Oh, this is one of the coolest things. I wish you could feel it too. It's gotten really hot very quickly. What happens is that small metal disc, when it snaps, it actually activates the liquid in here, the molecules, to begin to crystallize. This is called crystallization. And crystallization is when things move kind of from that liquid state to that solid state. From water to ice is also a crystallization. And we can feel it getting really warm. So what is it? Exothermic or endothermic? If you said exothermic, you were correct. If the heat is going from the packet out into my hands or out into this room, it is leaving the reaction. It's going from the reaction to someplace else. We call that exothermic. This one is exothermic. Unlike these other ones we've seen though, this one's actually reversible. I can take this home, boil it, and the boiling, where I'm adding heat into the pack, will actually begin to loosen those molecules back up to where they melt, and it will stay the liquid form again. And it will stay liquid until I snap that disc and start the crystallizing process over again. So this is an interesting one because it can be reversed back and forth. An awful lot of the experiments we do that are exothermic and endothermic really only go one direction because the materials that we've put in have been used up. They've reacted and they are complete. At this point, the reaction is done and can't be reversed, whereas this one can be. So not all exothermic and endothermic reactions are chemical reactions. Some of them are changes of state, making them just physical reactions. So what's actually happening in all of these? Where is that energy coming from? So it's really coming from inside the molecules itself, from the bonds between atoms. So atoms are much like this little magnetic toy. They have bonds that hold them together to form larger molecules. When you're pulling the atoms apart in a molecule, that releases energy, and that energy has to go somewhere. And often it's released as heat or light. When you're building molecules and atoms are joining with others, you hear that small snap. That's a sound where the energy is being turned into a sound energy. In this toy, it's sound energy as you're putting things together. But with molecules and you're putting things together, it too is a heat transfer. In this case, the heat is going into as opposed to out of the molecule. So exothermic and endothermic reactions are all about atoms and the way they move and they behave with each other. Energy can't be made or destroyed, it only gets transferred. So it's all about adding energy or taking away energy. But whatever you do, the energy is still here, it's going someplace. It's either exiting or entering, but the energy is always active. Let's try this. Inside your kit, find your graduated cup, a thermometer, some vinegar, and a small amount of baking soda. You've probably seen a reaction between vinegar and baking soda before, but you've probably never taken its temperature. You've never tried to figure out if this is an exothermic or an endothermic reaction. So today, let's find out which it is, and let's also try to make a graph, which will be a model of the actual reaction. We're going to look at how the temperature changes over time and see if we can make some predictions from that. To begin, let's take the temperature of the vinegar. Because it's been sitting in my kit, it's probably room temperature. So I'm going to put in the thermometer, give it a few seconds to reach temperature, and then read the results. Mine currently says 48 degrees Celsius, and I would record that onto my graph. Next, I'm going to add the small amount of baking soda that comes in the kit. And to do this, I'm actually going to be watching the thermometer while I add it. Sometimes reactions happen quickly, and it's important that you're keeping your eye on it. I'm going to tip it slightly forward to make sure that the bulb at the bottom of the thermometer are actually submerged in the vinegar, so that when the reaction happens, I know that it's actually in contact with the liquid. If you have enough vinegar to come up, you probably don't have to tip it forward like I am. So I'm going to pour in the vinegar and watch that reaction. But I'm mostly watching the temperature on my thermometer. What you'll want to do is you'll want to watch it over a period of time, recording your data maybe every 30 seconds or every minute. And then watch that again for several minutes to see how the reaction changes. Record your data, see what you find out. I hope you had fun with us. Thanks for coming on out. Bye.